Hello, Spark fans, and welcome back to Advancing Spark, where we are on day 2 of the Data and AI Summit announcements. Again, sorry it's a whole week late after the event, but jet lag and things. So, we had day 1 announcements, and there's lots of Spark engine-based things, and we saw things like Spark Connect, we saw the announcement of things to do with Delta sharing, we've got clean rooms, we've got Databricks Market Space, all sorts marketplace, yeah, all sorts of new features that were announced to do with the Spark engine and to do with Delta itself. Day 2 traditionally is all about machine learning. We tend to have the MLFlow announcements, we tend to have some interesting announcements for data scientists, and this is no exception. We have some MLFlow announcements, got MLFlow 2.0, but there are also some other announcements that actually on the data engineering side people might still be interested in. We've got some improvements inside DLT, that's Delta Live Tables. We've got some things to do with Databricks workflows. So we'll start off with the machine learning bits, and then we'll talk about some of the new Databricks platform changes that might be interesting to people using the wider Databricks platform. That is the plan. As always, don't forget to like and subscribe. If you're new here, say hello down in the comments. I'll put over the link so you can go and follow stuff through. But yeah, let's go and have a look. Okay, so like we did last time, I've got the day 2 morning keynote open, and I've stepped through and kind of grabbed a few frames just to go and talk about. So kicking things off, we have the main announcement of MLFlow 2.0. Now, thankfully, I don't have to actually go and explain all of these different bits and get lots of different keynotes because we have a nice, super handy little blog from the Databricks team talking about a recap of the announcements that were made last week. Why we don't have one on the engineering side, I don't know, but we have one here, so we can use that. So inside the whole of the MLFlow announcement segment of the keynote, we've got 3 major things we're talking about. It's all encapsulated inside MLFlow 2.0. The theme for 2.0s, right? We've got Delta 2.0, we've got MLFlow 2.0. That's what we're talking about. So, number 1, we have MLFlow pipelines. This is all to do with reproducibility of pipelines. It's all to do with templating of pipelines. So when we're training a model and we want to do it in a reliable, repeated way, we can use a MLFlow pipeline. Because you've got an example here, we have some configuration that we pass in via YAML. So we can build this kind of templated, here's some building blocks that we want our training process to go through to prep the data to get in the right shape, to do feature engineering, and then we can pass environmental configuration into it via YAML. That means I can pick that whole process up, put it into different environments, and just pass in the various bits of config to run that in different environments under different test sets, under different circumstances in via that config statement. So it's all about reproducibility of that, say, pipeline. I can't use pipeline to describe pipelines. Gonna get nuts. It's about making these robust, repeatable units of work to produce our ML models. Now, obviously, that is me as a data engineer giving a very high-level explanation of it. And we'll get one of our tame advancing analytics data engineers in, data scientists, to come and give us a more detailed view about how ML pipelines works, how you go through the process of building one out, and lift the lid and show us what it actually looks like inside one. So, recommend looking into it. Loads of really good stuff with ML pipelines, but that's all we're going to talk about it for now. Okay, we've also got serverless model endpoints. So one of the things that we've heard, Databricks SQL Server is coming. So we'll be able to actually fire SQL queries and have it actually spin up a cluster on demand, return serverless style. So we should be getting nice, quick, transparent scaling up and down of the actual machines that are doing the work. We've heard about that. We know that's coming. And we're getting the same thing on the ML side of things. So previously, when we talk about model serving inside of Databricks, all it really does is it takes your model, it pops it onto a single node Spark cluster. So it's just a single box that has the Spark application running on it, and then it wraps it in an API, and then it treats that as your nice serving solution. But that's not great, honestly. If you suddenly have a huge amount of throughput, it's not going to auto scale. It's a single node cluster. It doesn't know how to auto scale. It's not going to get a bigger box. So you have to go back to the old ways. You have to think about concurrency and growth and maximum usage peaks when currently deploying things into model serving, which isn't the best way. Serverless model endpoints, that's kind of taking that apart, right? So we're going to be able to, one, spin these things up a lot quicker because it's using this big serverless bank of ready machines. We've got the normal example here, putting a payload in, seeing the requests come out. Again, similar to what we currently see in model serving. But then when we start to look in the metrics, we can see the number of replicas. We can see it's actually auto-scaling out copies and then load balancing across that model. So much more sophisticated, much better way of taking our real-time machine learning models, popping it into something behind a web service, and then allowing that to scale up and down and actually react to fluctuations in the workload, which is just so much better for trying to get something that's vaguely production grade when we're doing real-time model inference. Now, if you're doing big batch scoring, you wouldn't use the same scenario, right? In that case, you probably have it on your normal ETL cluster, your data engineering cluster, and you're passing things past the model as part of your ETL pipelines. This is just for when we're trying to spin up a web service and have other things ping this model in real time to do real-time scoring or semi-real-time scoring. So, model serving in a serverless way, one or the other, that's the second big feature that was announced that we can then look at. So super interesting to see. Final one, model monitoring. So one of the big things about when you've got a model that's live is actually getting some observability metrics out. I mean, is it still accurate? Has my data changed sufficiently that actually the model I originally trained is no longer accurate? People's behaviors have changed over time. Maybe I trained it pre-pandemic and then a pandemic happened and actually the way people used to behave just isn't how people behave anymore. All this thing, you see things called model decay. And so having good stats around how accurate your model still is it slowly degrading? Is it getting slower? How fast is it responding to various different requests that come in? All of these things are to do with model observability. So it's a little bit like saying, how good's the API? Is the API working in an engineering way as well as I expect it to? And lots of things to do with model quality. You can see model quality going down over time as the accuracy score decreases. The label drift, are we getting labels that we hadn't expected? We get a more detailed view of the various different features that we're putting into it and actually have they drifted over time in terms of the kind of the makeup and the shape of that data that we'd normally expect to see. Now, all of these things allow us to then build into how often should I retrain my model? How much does my data change? Should I automatically re-trigger a training in my model or just do a brute force and just automatically retrain it on a daily basis, a weekly basis, a yearly basis? You don't really know unless you've got observability data. So that's the third and final pillar of MLFlow 2.0 that we're seeing. It's just a lot of these stats, a lot of these things built in to the MLFlow framework to allow us to actually start digging into it. So again, that is coming for public preview as well. So if you're hosting models via Databricks, we'll have an element of model observability. Now, obviously there's a huge more load of depth inside there. There's loads of nuance and details, and it's for that model, it's not for that model, it supports this kind of capability, it's for that algorithm. How does it fit in with feature store and AutoML and the other kind of core components of the machine learning persona inside of Databricks? They are all questions that we will dig into when these things are available in public preview and we can actually get our hands on it, talk about it, show you what it looks like. So MLFlow 2.0, loads of stuff in there. I'll pop a link to this blog. It's worth having a look through and worth having a dig into some of those things. But we'll move on to other things. So another big part of the day 2 opening keynote was around Databricks workflows and having a look at kind of what that looks like now, some of the features in there. And there's some interesting things like conditional switches, so being able to put a variable in there and go, well, actually go that path and go that path. Some interesting things inside workflows that is like starting to move it, make it a little bit more like an ETL system, a little bit more like a fully fledged orchestration system. Because we've seen this evolution of workflows from this basic Databricks jobs when it was basically a simple agent, a dumb cron schedule trigger that kicks off a single thing with some parameters, now into, well, kick off this basic DAG, this directed acyclic graph of jobs, each of which can now actually pass things between them. We can have parameters going between them. We can have conditional switches to a point. Now it's not there yet. We're not at the point where we can say, go look up a list of things and then run this job for each of the things in that list. If that fails, go that path. On that fails, kick off a switch and do each of these things in sequential order. You don't have some of the more complex control flow that you see in other ETL tools. But it's getting there. It's seeing more investment. It's seeing more and more things come in there. So again, we had a bit of a dig into Databricks workflows and the work that the team have done, the sheer amount of concurrency and the sheer amount of orchestration that's going on behind the scenes to make those things work, and the sheer number of VMs that are being run by it, and the fact that it's a mix of Spark and non-Spark jobs. So interesting part of the keynote. Not too much in terms of feature announcements coming out of there, but more just an indication that it's a big evolving area that we should be looking at. So quite a short little update for that one. And then onto Delta Live Tables. So one of the things that we've seen in Delta Live Tables is you pick your cluster and you can say, well, scale up and down, but it's hard to control. So much more efficient cluster utilization, better handling of streaming, and kind of just adjustments to the different types of workloads. So just like a real investment into how these things are working is definitely interesting. And there's a couple of different points that we saw with Delta Live Tables, a bit of investment into how these things are working, some new features, some new tools. And again, Delta Live Tables, if you missed some of the previous videos, if you haven't seen them before, they went GA, I think about a month ago. But essentially it's an ETL framework baked into the heart of Databricks itself. That is, I can declare a couple of tables, I can use SQL or I can use Python to write out what these tables and data frames should look like. I can then feed it into a Delta Live Table pipeline, and that'll work out the dependencies between the different tables, work out the order it has to execute things in. It'll take care of just running it end to end in a restartable pipeline, and with, again, sharing a cluster, scaling a cluster, reacting to different workloads. It can be streaming, it can be batch, it can be mix of the two. And we can do things like we can now have mergers. We can do some more interesting ETL kind of bits inside there. And we've also got great expectations baked in, so we can use it to manage data quality and keep track of what rows are valid, what rows are not valid, kick things out if they don't match our validation criteria. Loads of things inside there. Go watch the other videos. So enhanced auto scaling and making that work better. Real nice enhancement to start using bigger Delta Live Tables, use it for more stuff, use it for streaming in anger. Oh, sorry, using British terms. Terribly sorry. We've also got track changes, or as most of us know, SCD type 2. Now that is an age-old ETL problem, right? How many of us, in terms of building out warehouses in whatever technology you use, have gone, get all Kimball, I want to do a slowly changing dimension. And for those not from a warehousing background, if I've got a record and I get an update to that record, if I have a type 1 slowly changing dimension, I just update that record. I just change the values and I don't have any history of what it used to be. If I'm using type 2, what I do is I actually add a second record. And that second record says, well, I'm active from this point until this point. And so I can actually see I have both sets of records are now still just real rows in my table, but I've got all the different temporal states a row went through. And then when I join to it, I have to join to the row that was active at the relevant time. Very different to Delta time travel. Very, very different concept. But yeah, really interesting in that kind of, this is now something we can just do as part of our Delta Live Table definitions. I say apply changes into my table from my stream of data, sequence it by this particular timestamp, store it as slowly changing type 2. Automatically going to add, you can see in kind of that little screenshot, we've got starts at, ends at. It's doing its start date, end date. It's saying, well, this record is active from this temporal timestamp to this temporal timestamp. If I'm joining to you, I need to know when that works. It's a real sign of where they're going with Delta Live Tables, of just really investing, one, in warehousing and Kimball style data modeling and getting people to actually model their data in a more analytical kind of way. And two, just, yeah, encapsulating, taking common things that we have built 1,000 times in a variety of technologies and going, well, okay, we'll just do that for you. Right, super, super useful. And that brings us on to the final of the announcements, which is kind of like that, but a gargantuan daddy version of all of that. And that's a thing called Project Enzyme. Now, Enzyme is, again, from what we've seen thoroughly inside Delta Live Tables, it's an extra query engine that sits on top of the Catalyst engine that just gives it more juice and more decision-making ability. And as you can see on here, we've got 3 different ways of inserting data. Now, if I was writing a bit of ETL, if I was writing something, I could decide how I want to go and write data in. That's not actually what those graphs are showing. I've chosen the wrong screenshot. Don't worry, bear with me. When we're applying changes of data into a destination table, I can overwrite the entire table, aka the traditional Spark way. I can do a partition switch. Again, we'll delete that month and insert a new copy of that month. And that might be super efficient when I know I'm fairly time-bound and aligned to the partitions that are changing. Or I can do a merge. Okay, well, actually, the records are scattered all over the place. Just merge these in, but do it efficiently. You look after yourselves. But deciding which of those techniques and myriad other techniques I'm going to use is my job as an engineer. I need to look at the data and look at the patterns and have a look at the kind of the nature of data change over time and make a real decision myself about how I should do that. Not with Enzyme. That's essentially what Enzyme's doing. It's having a look at the data that you're trying to apply inside an update statement, and it's saying, what's the best way? Uh-oh, well, you're doing a merge, but you're updating nearly every row. Hell, we'll just do a full overwrite. Or going, you're doing a merge, but actually it's only affecting one partition. We'll just switch it in, don't worry. So it's interjecting in the query plan and actually making a more sensible decision to use different types of update technique depending on the type of data loading that we're doing. Now that is all sorts of cool. It takes away a huge amount of complexity if we're dealing with data updates, and rather than having them loading 100 different tables, rather than me having to go through and have a look at the historical data loads for each of them to think about the best loading pattern for each table individually, we can just go, load my data. Do it in the best way, I don't care. And that is going to be great if it works. Obviously, it's new, it's a project. I've not seen a private preview of it, I've not seen a public preview of it. Don't know where it's going to sit in the grand scheme of the roadmap, but certainly to make Delta Live tables easier to use, to simplify how we can build it into a generic framework and just throw logic at it and go, I don't care, just build the thing for me. That's going to be really, really cool and really, really change how people think about doing data updates, data insertions, or I think as Mike called it, incrementalization, which is the most American way of saying I'm updating some data. I'd normally call that applying deltas, but because it's called delta, it doesn't make any sense anymore. Good. So that is it. That is the final piece that I wanted to go through from the day 2 keynote announcements. And you know what? There were loads of other little bits and pieces in there that we've not really had a chance to dig into. There's some things talking about a new way of actually exposing the Databricks SQL endpoints. You can get to it from lots of different places. There's a new update mechanism talked to around Delta, saying actually want to add some pointers. So actually you don't have to replicate the entire table if we're deleting just a row. We just add a pointer to it and that's much faster. Loads of little bits of detail scattered around. But these are the main things I wanted to go through. These are the main ones I wanted to hammer home and go, these are the cool bits that are happening. So Enzyme, new query engine, just for deciding how to insert data when we're using Delta Live tables. MLFlow 2.0, a few different products of MLFlow pipelines, the MLFlow serverless model serving, and model observability and model monitoring, all coming soon into the MLFlow workspace with loads and loads of actually useful features. Just kind of just inching further and further and further to show that MLFlow is a production enterprise grade way of handling your machine learning models in different states and forms. And again, Databricks workflows, just getting that little bit more polish, that little bit more functionality to make it better and better and better as an actual way of orchestrating our data. So loads and loads of stuff in there. Again, I do encourage you, go and watch the keynotes. They're still up there, they're still live. But watching those keynotes yourself to get all those little snippets of information that I have glossed over and summarized for you. But at least hopefully that gives you the main takeaways of the stuff I'm excited about. And yeah, as always, don't forget to like and subscribe, and I'll grab you next time.